Okay, I'm going to show you all today how to do the food calorimetry lab. So our goal in this lab is to figure out the energy content of different foods. So the first food that we're going to look at is a cheese puff. Now, how are we going to figure this out? So what we're going to do is we're going to burn this food. And we're going to put some water in this can, and we're going to use the burning food to heat the water in the can. And by figuring out how much heat the water absorbs, we are going to be able to figure out how much heat the cheese puff gave off. So here's what I'm going to do to start. I'm going to put this cheese puff on this holder. It's going to burn pretty good, and so I want to make sure that it's securely fastened here. And now I'm going to turn on my balance, and I'm going to take the mass of the food in the holder. Now I know you can't read the balance in the video, so I'm going to also show you a data table where I'll record all this. So you'll want to put this in your own data table as well. Okay, so the initial mass of the food and the holder is 8.01 grams. All right, so let's record that in our data table. Oop, fell over, but that's okay. All right, so let's record in our data table that the initial mass of the food in the holder was 8.01 grams. Okay. All right, so now we need to collect a little bit more data. All right, so we're going to use the burning food to heat up water that we're going to put in this Diet Coke can. And so I'm going to put 50 milliliters of water into this graduated cylinder. And I'm going to use the fact that I know that the density of water is 1 gram per milliliter to assume that the mass of water is 50 grams. Okay? Now I'm going to use a stir rod. Here, I'll move this up so you can see it. I'm using the stir rod to hang the can over the food. Okay? All right, so I'm going to get suspended above the cheese puff, and I'm going to lower it a little bit because I really want to make sure that all the heat from the cheese puff, or as much as possible at least, goes to heat the water in the can. Okay, so I have my water. Now I need to know how much the water heats up. So I'm also going to need to take the initial temperature of the water. So the initial temperature of the water, it's not moving at all, that seems like okay. Oh. Hold on, let's give this a second. The initial temperature of the water is 22.7 degrees Celsius. Okay? All right, so let's put that in our data table. The initial temperature of the water is 22.7 degrees Celsius. Okay. Now I'm going to take this candle lighter and I'm going to light the cheese puff on fire. Okay, now I don't want to, I want to make sure it gets lit pretty well because I want the whole thing to burn as much as possible. And once I think it's really caught fire, then I'll remove the butane lighter and I'll just let it burn on its own. Ah, there we go. Okay. Now I'm going to tell you, since you don't have the full sensory experience at home, that this thing stinks. Smells real bad, okay? So, you know, just be prepared for that. All right, so we see that it's really, really burning. You also see soot collecting on the bottom of the can. And off we go. The cheese puff really burns. Now, if you can look really closely, you probably can't see it in the video, but you actually see bubbling. That's the fat in the cheese puff basically boiling. Now, it looks like it's like really, really out of control. I promise it's not. If it falls onto the bench, that's no big deal. The bench isn't going to catch on fire, but man, it is really heating up the water in that can. Once the flame starts to die down, I will measure the water again. Whew. I am intentionally doing this near the window because this smells pretty bad, and I will open the window once we're done here. All right, so the flame is starting to die down, so I'm going to see where our temperature is right now. Oh boy, it's going up quickly. So I'm going to record the maximum temperature that I see because over time, the water is going to lose heat to the surrounding environment, and so the temperature will go down if I wait too long. Still going up. Right now we're at 67.5, 68. Still going up. I'm at 70.1. It seems to be leveling off. All right. 70.1 was the highest temperature that I observed. So now I'm going to put that in my data table. Okay, so my maximum temperature was 70.1. So one cheese puff heated up that water pretty well. All right, so I'm going to allow you to calculate the change in temperature by taking the final temperature minus the initial temperature. And now we need to take the final mass of the food in the holder because I really want to know how much mass actually burned. Okay, so let's take a look at our food. Oh, that got nice and crispy. And come over here to our balance. And the final mass is 6.28. All right, so let's look at our data table and figure out what that means. The final mass is 6.28. So if I want to figure out the change in mass, I'll have to take 8.01 minus 6.28, which in this case will be, 1.73? 1.73. Okay, so that's the number that I'm really focused on for the mass of the cheese puff. And then I'll need to calculate the change in temperature for the water. Now, with this information, you're going to be able to calculate the heat that the water gained, and you're going to assume that that's the same amount of heat that was given off when we burned 1.73 grams of cheese puffs. Okay? All right, so I'm going to go ahead and pause the recording so that you can make sure that you have that down.